Okay, so by method of interpolation, you need to calculate the tau c. So tau c calculate करने के बाद आपको tau c की value मिलती है something 0.46. So now for D 100 mm, refer your IS code clause number 40.2.1.1. जब भी आपका D 100 mm रहता है, so the value for K constant is 1.3. So you need to calculate for D 100 mm, you need to calculate K. So the value for K you will get from the clause number 40.2.1.1 of IS 456-2000. So K into tau c आपको इसमें से मिलता है 0.6 megapascal. So as tau v is less than K into tau c, your design is safe for the shear. So do the check for the shear, and after completing let me know so that we can do the check for the deflection. And if you are having any of the doubts up till here, you can ask. Okay, completed up till here. Shall we proceed further? Okay. So now we need to do the check for the deflection. So for check for the deflection, again deflection के लिए आपके पास में formula है Fs will be equals to 0.58 into Fy into AST required upon AST provided. So already you had calculated AST required and AST provided. उसपे से you can calculate this value. So the value comes up to be 161.75 megapascal. और percentage minimum आपको कितना मिला है? Percentage minimum you had got that is 0.465. Just now you had calculated the percentage minimum that is 0.465. So percentage minimum आपको मिला है 0.465. तो ग्राफ पे से again you need to refer your IS code page number 38. Refer your IS code page number 38 figure number 4. तो जब भी परसेंटेज आपका 0.465 रहता है, so उसमें से modification factor that is MFT you will get it as 1.7. So D will be equals to L effective upon 26 MFT. So 2500 L effective is 2500 upon 26 into MFT that is 1.7. इसमें से D की वैल्यू आपको मिलती है 56.5 mm. That is less than the previous D that you had calculated earlier. So here your design is safe for the deflection. So do this check. See whether you are also getting the same answers or not. If your IS codes also with you, so that it will be easy for you to take the values from that. Okay, completed. Okay, what about others? Only one student is replying from. Yes, all the others had also done. Should I proceed further? So SD is 56.5 mm. Your design is safe for the deflection. Now you need to calculate L0. That is the length of anchorage. That is B by 2 minus 20 plus 12 phi. So here you are going to consider 300 mm as a width of the outer beam. So यहाँ पे आप जो consider कर रहे हो that is 300 mm the width of the outer beam. So we have to take it as 300 mm because in question में क्या mention किया है? In question they are mentioned that the external wall should be 230 mm. So we have 300 mm, not 230 mm because we can provide or place a bar in 300 millimeter thick beam. So thickness of the beam should always be greater than the thickness of the wall. So thickness of the wall आपको कितना दिया हुआ है? Thickness of the wall is being given to you that is 230 mm. इसीलिए हमने thickness of the beam ज़्यादा provide किया है that is 300 mm. So always remember that thickness of the beam should be greater than thickness of the wall. Otherwise आप साइड में नोट में लिख सकते हो that thickness of the beam should be greater than thickness of the wall and that's why we had provided the width of the beam as 300 mm. Otherwise, we can provide it as 230 also. But as 230 is given to you, इसलिए हमने 300 provide किए हैं. So considering 300 mm as a width of the outer beam. So L0 हमें कितना मिलेगा? 300 हमने assume किया है. So 300 by 2 minus 20 plus 12 into diameter of the bar. So diameter is 10. So L0 हमें मिलता है 250 mm. Now 1.3 into m by v plus L0. Now again you have to substitute the values of movement and shear force over here. अभी यहाँ पे कौन सी movement और कौन सा shear force substitute करोगे? The values that you had calculated in the bending moment and the shear force calculation, from that step you have to take the minimum values. So see that. तो minimum movement आपको मिला था 4.495. So minimum movement you are going to consider from there and the minimum shear force that is 11.06. So उसमें से आपको इसकी वैल्यू मिलती है 778.3 mm. So first of all do up till here, then we shall proceed for the LD, that is the development length. After completing, let me know, and if any doubts you can ask. Sorry. Yes, completed. Everyone had got the answers up till here. I hope everyone had make a note of that thickness of the beam should be greater than thickness of the wall. That's why we have taken 300 mm the thickness of the beam. Okay, completed everyone. Should I proceed further? Yes, please let me know. Okay. Then LD will be 0.87 Fy into 5 upon 4 tau BD. Now Fy is 415, diameter of the bar is 10, then 4 into tau BD as 60% increased deform bars we are going to use. So we are going to take it as 1.6 into 1.2. तो इसमें से आपको LD की वैल्यू मिलती है 470.1. So as development length required is less than the development length available, so your design is safe for the development length. So do up till here, then we will start with the further design of beam B3. After completing, let me know. हो गया सबका यहाँ तक के? सबको मिल गए आंसर्स? What about others? All the others had also got? Yes, Mohan. Okay. We'll start with the next design, that is design of beam B3. So for design of beam B3, we are going to consider the depth of the beam. So the depth of the beam will be span by 10. Now go to your diagram, very first diagram that is given in the question that you have drawn. तो उसपे आपका span देखो कितना था? Span is total 6000. See here, this one. This is your total span. Span कितना था यहाँ पे 6000. So just we are going to substitute the value for the span. That is 6000. So you have to consider the depth of the beam as span by 10. तो अभी आपका span कितना है 6000. So 6000 by 10. So आपको depth मिलती है 600 mm. Now you are going to provide the effective cover of 50 mm. You are going to provide the effective cover of 50 mm. So 600 minus 50, you will get the effective cover. You will get the depth as 550 mm. So since as you know that wall thickness is 150 mm, so we will consider the width as 230 mm. यहाँ पे बीम के लिए उन्होंने वॉल थिकनेस कितनी दी है आपको क्वेश्चन में 150 mm, बट हम यहाँ पे again we are going to consider the thickness width as more than that of the given thickness of the wall. So we are going to assume it as 230 mm. That is the width of the wall. Then we shall proceed for the loading calculations. First of all, complete up till here. Then we will do the loading calculations. Okay, over. Should I proceed with the calculation of loadings? In last sum, we have taken D equals to L effective by 15. So as the last sum is for the simply supported and this sum is for the continuous beam. So continuous beam के लिए जब भी आप beam solve करोगे तो तब आपको span by 10 लेना है and for simply supported case you have to take it as span by 15. Sorry, L effective by 15. Okay, so calculation of loading. So now calculation of loads you need to calculate. So the self weight of the beam. V3 weight. Yes, the beam V3 is simply supported only. So as you are going to take a L effective by 15. So यहाँ पे आप ये आप कौन से स्लैब के लिए डिजाइन कर रहे हो? This is for the continuous slab. And here you are going to design for the beam B3. So beam B3 के लिए आप जब भी डिजाइन करोगे तो beam B3 क्या है आपका? सिंपली सपोर्टेड बीम है. तो सिंपली सपोर्टेड के लिए आपको टोटल स्पैन लेना है, टोटल स्पैन बाय 10 लेना है. सो आपका टोटल स्पैन यहाँ पे कितना है? 6000 बाय 10. तो आपको डेप्थ मिलेगा, डेट इज 600 mm. Now we shall proceed for the calculation of loading. Now the self weight on the beam. Self weight on the beam is B into D into density. So B यहाँ पे कितना लिया है आपने? Width कितना लिया है? 230, that is 0.23 when you are going to convert it in meter. And the depth is 0.6 into density, that is 25. Here already we are multiplying it by 1.5. So into 1.5, so you will get the self weight of beam, that is 5.175 kilonewton per meter. Then you need to calculate the load from slab. So load from slab के लिए जब भी calculate करोगे तो सबसे पहले आप क्या लोगे? अभी आपके पास ये क्या है? टोटल डेड लोड. टोटल डेड लोड देखो आपको स्लैब के टाइम पे कितना मिला था? टोटल डेड लोड स्लैब के टाइम पे you had got it as 6. So 6 is nothing but the total dead load. This is your live load and this is your middle one. That is 2.5 by 2 as it is your 3 span slab है. So this that is 2.5 by 2. ये बीम B3 है और ये बीम B3 है. तो इसके लिए हम डिजाइन कर रहे हैं, इसलिए ये 2.5 by 2 लोगे और ये 2.5 by 2 लोगे. And total load, dead load and the total live load you are going to consider over there. तो टोटल डेड लोड एंड लाइव लोड कितना मिला था? 6 प्लस 4.5 और ये स्पैन का दैट इज 2.5 by 2 प्लस 2.5 by 2. सो टोटल लोड फ्रॉम द स्लैब आपको मिलता है 26.25 किलो न्यूटन पर मीटर. एंड द वॉल लोड, अभी वॉल की थिकनेस हमने कितनी ली है? दैट इज 0.15 इंटू 3 इंटू 20 इंटू 1.5. No need to multiply it later. We are multiplying it now only by factor of safety, that is 1.5. So it will be 13.5 kilonewton per meter. And total, you have to calculate the total load, that is the self weight of the beam plus the load from the slab as well as the wall load. So total load आपको मिलता है 44.925 and approximately it will be equals to 45 kilonewton per meter. So do these calculations. And after completing, let me know. Yes, Anis, that D equals to LE by 15 and span by 10. I will check once again and I will let you know by tomorrow in tomorrow's lecture. In some books it is given LE by 15 and in some books it is given span by 10. So I will check once again and I will let you know. Yes, I will repeat. स्लैब के लिए देखो आपको सबसे पहले क्या लेना है, डेड लोड लेना है. तो टोटल डेड लोड आपको कितना मिला था, 6 मिला था. फैक्टर डेड लोड आपको मिला था 6. देन फैक्टर लाइव लोड यू हैड गॉट इट एज 4.5. देन see the go to the diagram, see your diagram for beam B3. B3 के लिए डायग्राम देखो, B3 का स्पैन कितना है, 2.5 का स्पैन है. See, this is your beam B3. This one is B3 and this one is B3. इसका total span कितना है, 2.5. So this half of the load you have to consider from this total span. So 2.5 by 2 plus this 2.5 by 2, you will get the total load from the slab. Dead load, live load plus span by 2 plus span by 2. That will be the total load from the slab. So in that way, you are going to get it as 26.25 kilonewton per meter. Okay, all of you are done up till here. Should I proceed further? Okay, यहाँ तक के सबका? Okay. All the other side also completed. Should I proceed further? Okay. Now you need to calculate the bending moment and shear force. So for calculation of bending moment and shear force, you are having the formula for the bending moment, that is WL square by 8. And for shear force, you are having the formula that is WL by 2. So यहाँ पे, sorry, यहाँ पे आपको W की वैल्यू कितनी मिली है, just now you had calculated the value for the load, that is 45 into L square, that is L कितना है, total length कितना है, 6 for the beam, so 6 square by 8. So bending moment आपको मिलता है 202.5 kilonewton per meter. Then shear force also you are having the value, that is WL by 2. So just substitute the values for total load and the length. You will get the shear force, that is 135 kilonewton. So do up till here, then we shall proceed for the further. Yes, done with the bending moment and shear force. Should I proceed further? Shear force bending moment मिल गया सबको? Had you got the values for bending moment and shear force? Yes, completed or not? Yes, Tanveer, Omkar, Rita. हो गया यहाँ तक के? Okay, now we'll proceed further. Now you need to design. First of all, we will check whether considering the rectangular section, we are going to design while considering the rectangular section. So first of all, we are going to check whether our beam is singly reinforced or the doubly reinforced. To check for the singly reinforced or doubly reinforced, first of all, you need to calculate the moment of resistance. So moment of resistance calculate करने के लिए आपके पास में formula है, that is 0.138 BD square FCK. So 0.138 BD square into FCK. So substitute the values of all width, depth and FCK. FCK is 20, B is 230 and the depth is 550. So moment of resistance आपको मिलता है 192.02 kilonewton meter. As moment of resistance is less than moment acting. Moment acting कितना है? Bending moment acting on the particular section is 202.5. So it is less than that. So we will design for the doubly reinforced section. So solve up till here. Then we shall proceed further. We are going to design for the doubly reinforcement or the doubly reinforced section. Okay, completed. Okay. So we are going to design for the doubly reinforced section. So just draw the diagram. This is your B and D. This is your diagram for the doubly reinforced section. This is the C1, C2, 0.446 FCK. Already this is being over in your TRCS. And this distance is nothing but D minus 0.042 X1. And this is your D minus D dash. So just draw this diagram for the doubly reinforced section. And those who are not given the attendance, give your attendance in the chat box. We are having last 2 minutes. And after completing, let me know. I hope everyone understood up till here. If any doubts, you can ask. Yes, any queries? Yes. Hope everyone understood.